All right. Hello, everybody. It's great to be here. I think it's really a great opportunity with all of the previous discussions and presentations and everything. I think I've been here throughout all the sessions, and in the back of my head, I'm pretty much threading a needle through all of these topics that we've discussed. And I think it's all kind of very, very nicely coming together to what we're about to discuss just right now. So I'm Panos Vagenas. I'm a research engineer at IBM Research in Zurich, but I'm also actually a technical steering committee member of the Docling project, which is what we'll be talking about just right now. So thankfully, I won't need to motivate the topic all too much, because you've heard from different presentations what this is about. But maybe to briefly recap, I see really dozens of people in here. I'm pretty confident everybody has to work with data and with documents in their daily work, and has encountered the complexity that comes with this sort of work. So what I mean by that is documents are ubiquitous, they're everywhere, and they come in all sorts of shapes, formats, layouts, you name it, right? So you may think you have your typical business reports, your data sheets, your research papers, what have you, and they will come in all these different styles, columns, come like landscape, portrait with these images or charts or text or all of this complexity. And of course, on top of that, you have the different document formats, like be it PDF, the Microsoft formats, like audio, text, what have you. So there's really a very large amount of heterogeneity in this whole space that one would ideally like to address in a holistic manner and not have to care about. Now, on top of that, when we think about the AI context and when we think about LLMs, what we need to know is that LLMs do not natively understand these documents. So, for example, an LLM cannot understand a PDF itself. So the foundational unit of what modern AI is about does not understand, for example, PDF. What this means is that everybody that presents a solution that, for example, incorporates documents means they have somehow bridged this gap, all right? And these kind of approaches, they most typically come with significant compromises, significant sacrifices in terms of cost, in terms of privacy, in terms of usability, and so on and so forth. So what we're going to see here, and of course in terms of quality, what we're going to see is our solution which we provide through the Docling project. So Docling comes into the picture, and what it is an open source, fully open source, permissively licensed technology. It's donated to the Linux Foundation, so it is bound to remain open source forever. And it is offered for free, to clarify that as well, because sometimes people don't understand. It is for free. It incorporates all of the years of the research we at IBM Research have been doing in this space in terms of very specialized, really fit-to-purpose models for documents in particular. And it also allows for the incorporation of third-party models as well, all right? Now, when it comes to using it, it means that you can use this technology across many, many different document formats, whether you're working with PDF, like Microsoft Office files, audio, Markdown, HTML, what have you. We are trying to really take all of that and deal with it in a similar way. Plus, we allow you to export in different ways. And how we do it is we take all these different formats and pretty much map it out to a single unified LLM-friendly representation, which is very, very important, and which is also a very rich representation, which allows us to do very advanced use cases, as we'll see coming up. Now, what has been also mentioned so many times throughout the sessions today, privacy, security. How can one offer guarantees on that one? Well, for example, if you have all of your code and all of your data never leaving your premises, that's a very good start. I'm kidding. I mean, it's all locally executable, so it means you don't have to share your data with any third party. So that's a very powerful capability that enables a lot of these regulation-heavy use cases, enables many things. Last but not least, we are very, very present in the ecosystem, so people can use our capabilities, whether they're building, for example, in Python, whether they're using like their CLI, whether they're using tools like MCP, MCP-based tools that were mentioned earlier, or with all the frameworks like LangChain, LlamaIndex, LangFlow, Haystack, CrewAI. We're very much everywhere in the ecosystem. Very good. So let's have a quick look what it can look like with Docling, right? So we have a document, you have an idea. This is actually for our DoclingNet data set. It has pictures, figures, tables, charts, two-column format with a table and so on and so forth. How we can work with it, we can just say Docling and convert, for example, to HTML, and this is just an instance of how it can work. What you'll see is that it took this PDF that you were seeing earlier on, and it converted it to an HTML that retains the document structure, crucially. So knows what is what was a paragraph, what was a heading, of which level, where was it like a figure, what was a caption, represents the table in very high quality, even though the table contained like multi-spanned cells and so on and so forth. So this gives you an understanding of, all right, we are able to capture and reproduce the internals of a document in very high quality. Who is behind that? Well, we are a core team of around 10 to 15 people based in IBM Research in Zurich that we've been driving this, and I'm part of the steering committee, as mentioned earlier. But we are also a huge community behind in the open source. This is even old statistics that we're talking about, more than 2,000 active contributors. And what is very important, this is actually coming directly from the Linux Foundation statistics. What's important is that these statistics actually come from many different companies. So we are increasingly moving this to become a really community-based project and community-driven project. It's not just only governed with an open governance framework. What you see here is just an idea of the great traction we've been able to gain already. So for example, within kind of a year, we've been able to become one of the top 500 GitHub repositories in terms of stars. We're at 45,000 stars. We've been #1 trending on GitHub leaderboards for the whole November last year. And yeah, I mean, we will come back to that, but you see, we have, now I think we're approaching 2 million downloads per month. So what this means is that the problems we are trying to solve and the kind of foundational level approach that we're trying at addressing them really speaks to a lot of users, a lot of builders out there, and they see value in that and they're using it. And who are they? Well, they're pretty much everybody. As mentioned earlier, we are part of a greater open community and ecosystem that is really important because it enables you to do all these partnerships, all of this collaborative work with this really multiplicative effect, if you want. Like we've been having great collaborations, obviously with guys like Red Hat and Hugging Face, as you'll see, but I mean, these people are also very much using Docling as well. And if I really look at this one very quickly, I'll just call out a couple examples that come to mind. Earlier this year, I was really just checking the CES conference of NVIDIA, and they were kind of doing an equivalent to the notebook LM capability of Google, if you're familiar with that one. They were doing a kind of PDF to podcast capability that they were offering. And I was very happy to see that they were using Docling in that. So I was like, okay, that's not bad. I mean, I think the day before yesterday, I saw that the United Nations are doing a really interesting challenge on some projects where people can contribute and provide capabilities for developing countries through the use of such open source AI tools, including Docling and so on and so forth. I mean, There's dozens of examples I can mention, but just to give you a quick sampling of the space here. All right? So why use it? Let's start with a simple question. Well, first of all, cost. Cost. It's free, but it's also cheap to run. So these models that we develop are very, very, very small, very cheap to run, and very fit to purpose. You see here, when Hugging Face created the largest PDF dataset, fine PDF, they used Docling and another VLM solution to produce this, and you can see that Docling was actually 50 times faster than the VLM was. So this gives you kind of just a hint at what is possible in terms of cost savings. Now, there's not just cost, there's also quality, and quality can be of paramount importance. So why not just go with the cheapest solution? Why not just employ kind of a low-level tool like, I don't know, PDFium or one of those that will just take a PDF and instantaneously spit out something? Well, because exactly what it will spit out will be something. So this is a table, and here you can see kind of the table content coming out of that. And you know the saying, garbage in, garbage out. So when you pipe this data in your AI pipeline, it will not grow into being something good going forward. So this brings a lot of noise and makes your downstream pipeline go wrong. We'll see more on that later. You see things that are missing, things that are broken. Now, why not just go with a huge model instead, right? So what I tried to look here is just, why not employ like a very large model? Because what we create are models in like the space of 250 million parameters, which is really minuscule. Let's take like a 12 billion parameter model like Pixtral or so, right? And what you can see is that such larger models are also facing significant challenges when it comes to representing documents. So it's not like there is this kind of nuclear option where one could go like, oh, I'll use a huge model and I'll take 100% quality. Well, no. So that's one of my favorite, I think, anecdotes in this area, where I don't know if any one of you is like familiar with the notion of vegetative electron microscopy. No? That's good, because it's actually a non-existing concept. But some parser parsed the content that's going across two columns as one thing, and then there's been dozens and dozens of like peer-reviewed literature written on that topic meanwhile, just because of some low-quality parsing that happened at some point. So this just goes to tell you, you cannot think you cannot pay attention to your data, your document pipelines. I mean, it is going to have an impact down the road. Okay, this just shows that Docling, okay, obviously is able to tell that apart. And also what I think is super important, it really comes back to the whole discussion we've been having about trust, right, about reliability. You make a question to a system, like here I'm showing kind of a RAG interaction, right? How many PDF pages does the Docling dataset contain? And you're getting back an answer, like, Docling contains 80,000 PDF pages. Well, I don't know, maybe it does, maybe it does not. I really do not know, and that's pretty much where most LLM, most AI interactions would stop nowadays. You make a question to a ChatGPT-like system, you get back an answer, and you're like, I guess. So what we are providing is the capabilities for having visual grounding. So you, as a human, remain in the loop and can validate right away if the result corresponds to the sources. So here you can see, since we have this rich representation, we are able to have kind of the bounding boxes of the chunks that were retrieved in RAG and tell you, look, the answer is this because here's where it comes from. So you're able to kind of validate that right away, which is, I think, super important and powerful for building trust, for being able to kind of move on to the next level of AI where, you know, this is very crucial. Otherwise, I think adoption is really limited on that side. All right, just quick glimpse under the hood, very quick. What we do is we take all the different formats that people can come with, and we just map it out to this single unified representation, which we call the Docling document. So this enables us to keep all of this rich metadata, all of this rich information on what a document actually is about in one single place, and standardize on that level. And that is so crucial, because once you hit that kind of vertical, once you get there, then you don't have to care about the document anymore. As a builder, it is gone. All of that complexity was absorbed here, I mean, by us. So that's, I think, what makes this so powerful, that across formats, in depth, with quality, we're able to provide a super powerful primitive to the builders that can take that and with our programmatic APIs, go and build things very easily, very powerful applications. All right. So just a quick glimpse also on the innovation that we're bringing into that. You see the VLM work that we're doing on the vision language models that are powering part of our pipelines. This is, for example, Granite Docling is the latest one, where we were able to get essentially on all categories of Hugging Face trending, we were there in the top 3. What the CEO of Hugging Face called the Grand Slam of trending. So that was also a nice kind of small milestone. For us, this is kind of the way we see forward, these VLMs, these vision models, which can in one shot go from the image to the representation that we're discussing about, this rich representation. I'm going to skip through the demo, but I mean, online you can essentially play with these VLMs also very easily, very interactively. You can just look it up on Hugging Face and so on. So, just the last couple of points. Additionally to what we've been talking about until now, we are also introducing a kind of an orthogonal and still very powerful capability to that, which is extraction. So instead of just coming in with a document and wanting to see an accurate representation of that document, there is this other use case where you come in with a document and with a very concrete idea of what you want from that document. So like you bring in an invoice or a bill or what have you, kind of probably a structure, say, a kind of structured document. Sorry for the contrast here, but you can say, that's my bill image, right? And I'm interested in the bill number, the total invoice price, and this and that. So you're getting that out of the box. So again, this is a different capability to what we've been discussing, but put these two together, and I believe you have a super powerful application plane on which you can build, very innovative ideas on how to leverage your documents and the information that's locked in there. Last but not least, obviously, we're pushing very strong on the agents side. We have obviously provided our capabilities on an MCP server level, so you can use it very easily whenever. You can use an MCP, plus it's plug and play in all of the low-code, no-code tools like Langflow and so on and so forth. So what it means is even if you're not a programmer yourself, it is really very much straightforward to click together a workflow that utilizes Docling in there, or you can just use it with MCP. So let's have a quick wrap up with a couple of takeaways. What Docling allows you to do is to automate all of the document workflows you may have, be it invoking AI or not. You may have a more traditional like AI workflow that you're doing. You can use Docling and accelerate your work on that one very much. It is super cost effective and retains high quality while your data doesn't need to leave your premises or your laptop or what have you. You can, if you want, connect to other things, but it's kind of an opt-in. We provide you the hooks where you could just, for example, say, look, for images, I want to run that other model that will go and annotate the image with this particular prompt. Yet another very powerful capability one can explore. And coming back to the VLM space, it's something that we're pushing forward very strongly. We want to be leaders in this space of the VLM. We've already had 2 very successful iterations where both hit #1 on Hugging Face globally. And we're working already, obviously, on the next ones. And last but not least, it is what any AI builder that wants to really not lock themselves in with any kind of vendor or provider, it's what you want to look at for building against documents. It will most likely be in the framework of your choice already, so you can just look it up and pick it up and try it out for yourself. So whether you're doing a RAG use case, like querying your documents, whether you're doing an extraction and so on and so forth, I really encourage you to have a quick look, or not quick look, to really explore it. That's the call to action at this point, really. Just have a look at docling.ai, download if you're a builder, you can just pip install Docling, for example, and give us a star if you like it on GitHub. You can help move this line further up where it says the count of stars. And join us on LinkedIn, on GitHub, and be part of our community. We're a very much active community, and we really appreciate the feedback we get back in from the users to improve what we're doing. So if you have any questions, any use cases, anything, feel free to hit me up. I'll be around, or reach on the internet. Many thanks.